Have you ever gotten to the end of a podcast or an audiobook and just felt completely wiped out, even if you were really into it? Well, today we're going to dig into some really fascinating research that explains why that happens. Turns out there's a hidden battle for our focus going on inside our headphones, and we're just now getting the tools to see it. 25. That's a big number. And in this case, it's the number of years a team of researchers has poured into one single mission: to finally understand how sound really, truly affects our brains. And after all that time, their work is finally ready for the world. So what you're looking at here isn't just a proud announcement. It's the culmination of a quarter-century of work. And that little thing at the end, a scientific DOI, that means this is a formally published, verifiable piece of science. It's got a permanent digital fingerprint open for the entire world to see, to test, and to build upon. Yeah, this is a pretty big deal. Okay, so why should we even care about measuring something called acoustic coherence? Well, think of it as a way to measure how orderly and natural a piece of audio sounds. And it matters a lot because it helps us finally see a problem that's been affecting all of us without us even knowing it. The researchers call it the invisible sonic impact. And honestly, this couldn't be more urgent. Right now, AI is pumping out millions of hours of audio content, podcasts, music, you name it. But what is all this sound actually doing to our brains? The real answer? Until now, we haven't really had the right tools to even ask the question properly. The problem really boils down to this: cognitive fatigue. We've all felt it, right? That feeling where your brain just feels drained and you can't focus. What this new research shows is that this feeling isn't just in your head. It can be a direct result of listening to sound that lacks that acoustic coherence, that natural, orderly structure our brains are wired to expect. This slide just lays it out perfectly. It's like two sides of the same coin. On one side, you've got sound with high acoustic coherence, which leads to clarity, focus, and a sense of well-being. But on the other side, incoherent sound. And that can lead to exhaustion, distraction, and even stress. It's a hidden battle for our mental energy, and it's happening every single time we press play. So if that's the problem, what's the solution? This is where that 25-year journey really pays off. The team hasn't just identified the problem, they've developed a new tool to fix it. They're called the FSE and FDT protocols. Now, don't get hung up on the acronyms. What's really important here is what they do. Think of them like a microscope for sound. They're two brand new, practical tools designed to measure that invisible quality in audio and actually predict its impact on our biology. So how do they work? It's basically a four-step process. First, they analyze all the frequencies in the sound. Second, they measure what's called its biophysical stability, which is just a fancy way of saying how orderly and brain-friendly it is. Third, that measurement helps them predict the impact on the brain. And finally, and this is the coolest part, they make the invisible visible. For the very first time, we can put an actual number on the quality of the sound we're consuming. But here's the thing. This research was never meant to just sit in some stuffy scientific journal. The creators want to start a movement, and this is their invitation to every single one of us. Let's build together. I mean, this quote just says it all. Instead of hoarding their research and keeping it under lock and key, they're throwing the doors wide open. They're literally asking the community, programmers, scientists, creators, you, to test their work, share what you find, and build the evidence together. This is so different from how science usually works. It's a total game changer. And they are not kidding around. The protocols are completely open source. All the code is available for you to download right now, written in Python and R, which are two of the most common languages for this kind of work. This thing was designed for collaboration from day one. And I think this philosophy is just so important. This isn't about pointing fingers or blaming anyone for the quality of audio in the past. It's about empowering everyone, from your favorite podcast creator to software developers, with the tools we need to build a healthier sonic future for all of us. All right, so let's say you're intrigued. You want to get involved. You want to see this for yourself. Where do you start? Here's exactly how you can jump in and help replicate this incredible research. First things first, go right to the source. The complete scientific paper is public. It's free. Just copy this DOI number right here into a search engine or a site like doi.org, and you can get the whole publication. Read it, question it, build on it. You can also connect directly with the organization that did all this amazing work, the Delta Foundation. This website here is the central hub for the whole project, so it's a great place to bookmark and follow for updates. And that really brings us to the most important part. The call to action is so simple, but so powerful. Subscribe to what the Delta Foundation is doing so you stay in the loop. Share this information with anyone who makes audio or just listens to a ton of it. And hey, if you've got the skills, try to replicate their findings. This is how real change actually happens, from the ground up. Which really leaves us with just one final massive question. After a 25-year journey, the tools are finally here. The invitation has been sent. So the only question left is, are we ready to start measuring the future of sound?